So, good morning, everyone. Hope everyone had a great weekend. Welcome to week 2 of the EAMS conference. We've got 3 fascinating talks coming up. Graham Clark from RMIT University in Melbourne is going to be talking to us about experiences with variable assessment data. So in particular, talking about the challenge of reducing the incentive for students to collaborate, which sort of picks up on some of the conversations we were having last week. James Davenport from University of Bath is going to be talking about the assessment of programming and teaching of programming. And finally, Christian Lawson-Perfect is going to be talking on the very important topic of making e-assessment inclusive for all. So looking forward to these 3 talks. After each one, we hope to have the opportunity to ask questions to the speakers. A reminder, please, if you could direct your questions to the Moodle questions link underneath the information for this session. The advantage of doing so is that we can continue that conversation far beyond this Zoom call. So that's the plan for this morning, and we're going to pass across to Graham for his recording first of all.
Use 3 kinds of data to individualize assignments. The assessment of learning.
Sorry, just realized there was no sound there. We'll start again.
The assessment of learning is perhaps the most challenging part of university teaching. I'm going to discuss some strategies for trying to create variable data for individual students. Why do we need variable assessment? Well, to be blunt, some students are naughty. To make it hard for the students to work together when they're not supposed to, we need to create variability in the questions that the students are answering. This won't guarantee that there's no illicit collusion, but it will reduce the likelihood of it by making it harder for students to work together. I've applied these strategies to both discrete maths, where it seems more suitable, and to calculus, where it's harder to implement. I've used 3 kinds of data to individualize assignments: randomly variable data, numerical data with individual parameters, and non-numerical data with individual parameters. By randomly variable data, I mean each student gets a certain set of data and there's no specific pattern as to how it happens. I used this in a group theory assignment where each student was given a different Cayley table. The students were required to identify the identity element, find the inverses of some elements, and so on. Each student received a 6-element Cayley table, which, unbeknownst to the students, were actually all isomorphic to each other. Well, the next question was how to get the Cayley tables to the students. And I suppose I could have driven around to their addresses, delivering them all to them, but instead I sent them as email attachments. So how did it work? Well, it took a long time. Then I hit on the idea of using a parameter instead. It seems natural to try a numerical parameter, and the obvious place to start was with the students' identity numbers. Now, if you interpret them as 7-digit decimal numbers, they're too big to be really useful, so you need to cut them down to size somehow. And the simplest way to do that is just to add up the digits. If the sum was prime, I asked the students to add 1 to it. Otherwise, they were to leave it as it was. This gave them their special number n. In the first example, they had to work out how many groups there were of order n, or do some research to find out the answer, how many abelian groups, what numbers might occur as the orders of the subgroups of a group of order n, and to describe all the symmetries of a regular n-gon. In the second example, if n was odd, they had to investigate the logical connective of alternative denial, while if it were even, they had to investigate joint denial instead. The fourth example was to do a bit of graph theory and to think about the complete graph Kn. Decide if it has a Hamilton circuit, a non-cyclic Hamilton path, an Euler cycle, or a non-cyclic Euler path. And then they had to use another number, p, which was the smallest prime divisor of n, and consider the complete bipartite graph Kpn. Does it have a Hamilton circuit, a non-cyclic Hamilton path, an Euler cycle, or a non-cyclic Euler path? And another graph theory example was given. A free tree with n vertices has how many leaves? What's the least and greatest number it could have? And a binary rooted tree with n vertices has how many levels? What's the least and greatest number of levels it can have? Well, the variation occurred when we had a list of 7 items and students had to pick one of those, but not to choose freely. They were to be assigned to the students. And the way to do that was to create a special index number. Add the digits in the ID number, divide by 7, write down the remainder, and add 1. Now, they had to start with this generator matrix for a group code and find a parity check matrix, H. Then they had to use the matrix H to produce the syndrome of their selected received word and make sure it matched the required syndrome in the list. A similar variation was given to the calculus students, where I wanted them to use a number which was to be 2, 3, or 4. They had to add up the digits in their ID number, divide the sum by 3, find the remainder, and add 2. Then they had to use this to answer a question about a circle and a question about a sphere, both having radius A. Now, the calculus students were less comfortable with this kind of question, or this kind of task, because they weren't familiar with the division algorithm, and some of them struggled with the idea of a remainder. The discrete math students didn't have that sort of difficulty. Now, there are some problems with the approach. One is that n, the special number, isn't always unique. And the other, of course, is that there's a lot more work in marking assignments that have variable data. Well, non-numerical data can sometimes be useful. And I use this for problems involving Huffman codes and language theory. We start with the student's name, but students' names are often too long, and I mean they vary a great deal in their style. So we decided to create a so-called special name using the first 6 letters of the official name. Then they had to insert that in a partially completed sentence to get something like, I am someone from RMIT, and use that sentence to construct a Huffman tree then a Huffman code, and then to encode the sentence. They also had to use their special name to create an alphabet and use that alphabet to create palindromes of various lengths, or to work out how many palindromes of a specific length there might be. The problem with that is that the special name might not always be unique, and also some students had trouble constructing it. But also, some names made the task easier for some students than others, depending on how much repetition there was in the names. If there were few letters that were repeated, that made it harder. Well, you could change the special name so that it always had 6 distinct letters. So overall, what can I say about this experiment? It seems a good idea to use a parameter, and a numerical parameter is more versatile, but sometimes the non-numerical parameter can also be very useful, especially in some areas of discrete mathematics.
Okay, thank you. And I think Graham joins us now. We can unmute you, Graham.
Yes, here we are.
Hi, Graham. Okay, so participants, if you would like to direct any questions that you have to the Moodle site, we've got one here from James Fody. She asks, did any student ever complain that her random question was accidentally more difficult than the corresponding question with another student just because of the data generated?
Well, fortunately, when they're not together, when they're a bit isolated, they don't necessarily know those things. So I haven't actually had any complaints about that, though I've been expecting some.
Colin Steele from Manchester asks whether students see the details of the algorithm for finding their value of n. I got the impression that they were doing this themselves. Is that correct?
Yes, yeah. I did, on a couple of occasions, give them advance notice, like work out your special number before you have to start doing this test.
Okay, I see. And can you tell me how the sort of submission process was organised, and in particular how you then went on to mark work from all these random variants of the questions?
Well, I found a very useful way to mark the assignments was to find a tutor to do it. But it was online submission was the way we did it. Now, the problem, of course, is that you don't know how long to allow students to do that. If you only allow them 5 or 10 minutes, then they start sending emails straight away saying, oh, my internet dropped out. But if you let them have an hour, then the chances are that they're going to be writing for much longer than they're supposed to, and then do a frantic scramble to try to upload in the last 5 minutes or so. And that's something we're still struggling to solve, that problem.
So, since the generation of the questions is quite algorithmic, did you consider doing some sort of automation for the submissions themselves to automate these things?
That would be good, but we'll have to find the right technology and work out how to use it before we can get to that.
Thanks, Graham. So one final question. So what happened? It's a question from John McDermott. So, what happened if a student came up with the wrong parameter? So was there a lot of error like this? If they come up with the wrong parameter, what could you then do to mitigate?
Well, some of the calculus students sent emails saying, "What's this remainder? I don't understand what I'm supposed to do." So I just quickly fired off emails to that group of students explaining it. So that just wasted like 5 minutes or so. It didn't matter too much. But where a student actually used the wrong parameter, there's a suspicion that they did so deliberately because they wanted to get the same parameter as their friend. Now, at this stage, we're being a bit tough and requiring the student to explain themselves. And in the exam assessment committee, we may decide to be lenient about that.
How were these assessments very high stakes, or were they worth a lot of credit for the students?
Well, they added up to quite a lot. Each one was between 15 and 20%, but they're adding up to about 50% overall.
Right. Okay, that's interesting. Okay, thanks very much, Graham. We're going to move on. So there are a couple more questions there on the Moodle site. So if you're able to pick up those, that would be fantastic at the end of the session. We're going to move on now. So our second speaker is James Davenport from the University of Bath, and he's going to be telling us about his experiences with the e-assessment of programming. So we'll run that video, hopefully with sound now.
Good morning. Pre-traditional programming courses assessed by major courseworks and examinations. The teaching staff and tutoring staff has significant overlap, but very similar students. Good morning. My name is James Davenport. I spent 10 years teaching mathematicians how to program and using e-assessment. I want to talk a bit about my experiences here. I'm obviously grateful to many tutors, notably Ian and Steph, who helped me over the years in delivering this course. So what's the context? Well, long before the Bond report, Maths at Bath had always taught programming. It was Fortran when I joined, and I took it to C and so on. In 2001, computing split from Maths, and actually both of them went to Java. Different courses, different credit counts. And Java, of course, is a popular language for teaching, as we discovered when we did our survey, and indeed in industry. So the industry statistics show that Java is just about ahead of C. It's the most popular language. Those for the top 10. In fact, MATLAB is 11th. So it's not a completely silly language. Pre-traditional programming courses assessed by major courseworks and examinations. The teaching staff and tutoring staff has significant overlap. They're very similar students in terms of grades. Many of them went on, in both cases, to do thick sandwich courses. Nevertheless, the computing course was a success and the maths course wasn't. Essentially, the answer to that was that the maths students were there to do maths, not programming. So our solution back in 2009 was to change the maths course. It was programming and discrete mathematics. We changed the language to MATLAB, but it was a programming course. It wasn't a how to drive MATLAB packages course. And that course described the paper we wrote last year. So I'm not going to talk more about that. I'm going to talk about the assessment. So it was assessed by individual coursework. And in the old course, students would leave the coursework to the last minute, find they couldn't program and fail. And some years we had a 40% failure rate, which was painful and embarrassing and caused a lot of resits, etc., etc. You know all that. So therefore, the solution, which I picked up from a colleague in Canada, was to have weekly formative exercises, which were assessed on pass-fail basis by the lab tutor. Is it computing the right thing? And we set exercises such that it was easy for the lab tutor to verify that. The stick was, if you don't get enough exercises, your coursework mark is reduced. We did that for a few years until we had enough data. So the carrot could be, the evidence was, if you don't do the exercise, you fail the coursework. No one who did not complete at least half the exercises ever passed the course. And that actually works quite well. So we've dropped the stick now. However, we also need the formative coursework, which is one per semester. Each of them was worth 25%. The other half was the exams. Number of students started at 220 the first year I taught. The greatest number was 330. The coursework marks were 80% correctness and 20% style assessed by the tutors. Style always caused a lot of problems. The tutors it was very hard to make the tutors be harmonious. I'm not blaming them. We all have different views about style and also different views about correctness and so on, however much you help them. So I really wanted to do the correctness marking automatically. 15 tutors is hard to manage. My thoughts were this: it's much easier to mark a function than a main program. You can write all sorts of tests to call the function. it's actually also much more realistic. I mean, most of us spend most of our time writing functions. We don't actually write that many main programs. I also thought Moodle is our VLE. It's quite a good one. We're going to handle submission, and we can also program it to handle extensions and the office stuff for extensions in and so on, and the reporting of marks and all that sort of thing. Indeed, the office wanted just one mark, so I had to use Moodle to add the style marks and the correctness marks and so on and so forth. All much easier than messing around with separate spreadsheets. The only trouble is it meant they had to zip of their code, and Moodle will accept RARs and so on as well, and things that wouldn't unzip properly. And I'll talk about this later. My typical problem, I had others as well, but this is what I'm going to talk about, was we asked them to evaluate a polynomial by Horner's rule, except it was a matrix polynomial. And of course, there are pitfalls in setting the same coursework every year. So what I actually did was in alternate years, I swapped the coefficients of the x's, because of course matrix multiplication is not commutative. You'd always check with students who pick up a solution from last year that way. It was remarkably effective in discovering that. The other trick is you make sure that there's some tests when B1 is not 0, and you find students who spot the commutativity test for that, but not for the last multiplied by x power B0. And then there are various extra variants. So for more marks, I would ask them to deal with the case when the BI were not sorted, or deal with the case when you actually had to cache the powers of x to avoid recomputation. And those were sort of the part of the coursework where I got the extra marks. My first pitfall was that students can't read specifications. However much you try, however much you get the tutors to debug them, the tutors say yes, and you read their solutions, they all read it and so on. They're used to it. First year students are not. And in year one, the first time I ran this, 40% of the functions being handed in could not actually be called. MATLAB just couldn't find the function with the right name and the right number of arguments. So my first idea was I would give them the function header. Second idea was to actually give them a trivial test of the form I was going to use, exactly of the form I was going to use. Typical test, for example, n could be 2, and I could use 1-by-1 matrices and so on. In fact, I strongly recommend tip 2 in terms of I got many fewer poor submissions with tip 2 than with tip 1. So I got to tip 2 in year 3. Tip 1 still lets corrupt return value, and they will. Pitfall, again, they can't read the how to hand in the specification either. So you get folders inside the zips, you get missing functions, you get people handing in RARs rather than zips and so on. The first year I did this, I spent an hour debugging the hand-ins. So what I actually did was I got a TA to do the unpicking, and after a couple of years, one of the TAs just wrote a verification tool, which the students could use to verify they actually got a submission that was valid. Thank you, Ian. That was a really helpful piece of work. Thank you. Another thing to remember, and this is not well taught, is that timings on laptops don't work. I emphasize this to students. The point is, the reason timings on laptops don't work is that when a laptop gets hot, it just automatically, without your noticing it, turns down the frequency and runs slower. And you can get some beautiful sinusoidal effects here. And they totally destroy any ability to do sensible timing. I always tell the students this. I warn them that they should use it on the university mainframe, but they don't. The other trouble is that students are incapable of writing incredibly slow code, to my eyes. So you can't actually rely on the timings. So you never look at absolute times, always look at relative times as n increases. But my strategy was take a small n, keep doubling it until I find some n0 where the time for n0 is greater than 1 second. So it's pretty reproducible at that point, timings on a Linux machine. Then I take log t of I times n0 when I is 1 to 5 and fit a straight line. I would sort the slopes. And so the slope is 1 for linear programming, 2 if it's a quadratic algorithm, and so on. Then you generally see a natural break at about 1.1 or 1.2, because the algorithm is probably n log n rather than n. Look by hand at the solutions near the break to convince myself I've found the right point, and that's actually remarkably effective. The appeals, I typically get 2 to 4% appeals, which are typically variance on students forgetting that in MATLAB at least, if you do for I equals 1 to m, ai equals I, that's actually OM squared because the array has to keep growing. And you can get some effects in other programming languages. They're constructs which look trivial but actually have a hidden cost. And so I always tell students they should verify their complexity experimentally. The way I'm going to do that, the last few years I actually gave them the scaffolding code that did that, finding n0 and computing the slope of a curve. I gave them that code. They don't do it, but still, that's life. You give it to them, and probably some of them do it. The other problem is actually choosing the test data. It's very easy to write a set of test data which is bimodal. Half the students fail it and get 0, half the students pass them all and get 100%. And certainly the first few years I found that I was doing like this. I had to go back and rewrite my test data often 2 or 3 times and rerun it. I realized I was not, in particular, it was very easy to have lots of students on 0. My first tip is you really give them a test if you're on tip 2. I give them the same test and variance on that, probably up to about 40%, sort of matching the sort of bookwork ratio you give in an exam. On the other hand, I reserve a few marks at the top for really messy edge cases. So one, for example, I quoted, one is n being 0. The other is non-square AI. X has to be square, but the AIs need to be compatible with X. And if you've written the specification correctly, that's legal. You don't just give that many marks for it because it's being a bit unfair. You give some, so distinguish the really good students from the, sort of starred first from the first is first. And this takes a bit of thinking, in my view, and actually it can take going back to the problem as well and making sure you've got the wording such that you're allowed to put some messy edge cases in like this. Not many marks, but some just to get some discrimination at the top. And better references. Thanks very much.
Thank you very much, James. Hopefully you can join us now. First of all, just before before the talk started here, you mentioned plagiarism. Was this an issue that you experienced with these assessments?
Yes, it was. My solution to the plagiarism question is to run all these solutions I get through MOS, the Stanford Measures of Software Similarity tool, which eats practically all languages and produces a measure of similarity. Be careful to say this is not necessarily plagiarism. Remember what I would do is I would work my way down the MOS correlation coefficients until either I ran out of time or I was getting to the point where it wasn't obvious to me that there was some duplication here. And you'd see all sorts of excuses. Not excuses, that's not my favorite. Explanations. I gave him my solution, or cases where one student didn't know their solution, the other person had either picked up a listing and retyped it, or something, or gone in and poked pinch apart their file, maybe something like that, and so on. Or you get collaboration and so on. But I found MOS was really very, well, to my mind at least, it looked very effective. Anytime tutors got worried, MOS also got worried. And by and large, the MOS correlation coefficients seem to work pretty well for detecting it. But of course, it's always quite high in the sense that the problem is pretty similar. There's a fairly obvious solution. So you actually expect pretty high similarities. So, I mean, this is a long way from being an open-ended problem. What I gave, and many of the others. So you expect high scores, and it's very important to eyeball MOS. You can't just take it, but it does give you a really good way of just working your way down the list of likely similarities. So I strongly recommend that. That was my tool, and other than the slight tedium, I have the pain. I have no real complaints about it.
Thanks, James. Just following up there, did you use MOS as a deterrent for students not to collaborate? Did you? I
tell them I'm going to do this, and I occasionally. Some years I read out a horror story from previous years. Some years I didn't. Depended how I was feeling, I think, really. But I did also warn to be careful, because I always told them there were cases of people literally stealing solutions from other people. Yeah. I always told them that happened, which in fact it happened. Probably about half the years I taught this course, there was a case of student A doesn't know the student B's hand in student A's work.
Okay, thanks, James. So Tim Hunt had a comment on the Moodle site there. So he pointed out that there are tools such as Code Runner, which is a Moodle question type for assessing programming tasks, and there are other tools to do these things. You had quite a large class here, if I recall. So how long did this take to mark, and was there opportunity to do some of that automatically by sort of scripting tests?
So the marking was completely automatic. Once I wrote a bunch of tests, ran them through, and that produced a CSV file which I uploaded into Moodle.
You mentioned in the talk spending some time eyeballing solutions and
for the timing ones, yes. The timing ones, I'd run that, and then I'd eyeball to work out what the correct cutoff point was. But that was essentially eyeballing the few of them near what looked like the natural break in the slope of the performance curves. So then I go back to the solutions and check that the ones at the top but below the natural break were n log n, and the ones, or maybe n log squared n. I frankly didn't care. And the ones above it were variants on quadratic. But that per se did not take long. Running the test took some time, just because you start off at 1 second, then you increase it, then you find a bug in your test, which you have to run again. So it would take me probably a week full time to do the automatic marking of 300 solutions.
Thanks. Okay, a question from John McDermott. Did you release the validation tool that was developed there to students in advance and require?
Oh, the validation tool, yes, that's the whole point of it. You release in advance to say you should make sure that your code passes validation tool. This will ensure you've got a valid hand in. That's the whole point of validation tool, is to take the pain away from the tutors. Yeah.
Yeah, absolutely.
That clear. My fault.
And just a final question. So how did the assessments that you described in the talk, how did they fit into the overall assessment of the module? Was there a final exam, for example?
But yeah, so 50%. The module was an all-year module, so 25% on each of two courseworks. I taught for the first few years. I taught the whole year, and so I had 2 courseworks. And then later on, I only taught the first semester, and someone else taught the second semester and had their own coursework. But so 50% coursework, 50% exam. The exam was typically more on the discrete maths side of it, but would have some sort of abstract complexity theory in it and so on, and some graph theory and that sort of thing. But the programming side of it was purely assessed by the courseworks.
That's interesting. Thank you. Thank you very much, James. We'll move on now. So our final speaker of this session is Christian Lawson Perfect, who's going to be talking about inclusive e-assessment.
This talk's about inclusive e-assessment. It's not something I'm an expert in, but it's something I care about. I'm going to draw from my own reading on the subject and my experiences designing e-assessment to give you some ideas for ways you can improve your assessments. First of all, these slides are done in a nice colourful handwritten style, which I enjoy, but there are captions on the video version and a transcribed version on the conference website. This talk could have been called, "Who are you not designing this for?" The problem is that it's easy to imagine a student just like you while you're designing an e-assessment. And anybody else who's different because they have particular requirements or just come from a different background, you might have to make some effort to adapt to them. That's called the deficit model. Another way of doing things is to think about all of your students before you implement your e-assessment and design for everybody. The best outcome of inclusive design is that when an issue arises and you need to make an accommodation for a student, you can say, well, this student's already catered for. Now, I'm a privately educated, straight, white British male, so many of the things I'm going to talk about, I've heard about secondhand, to be honest. So the things I'm going to talk about are from my perspective. You might do things differently, but the idea that you should be thinking about other people than yourself, hopefully, is transferable. I've come up with 3 kinds of barriers to inclusion. First, subjectivity. These are largely cultural aspects that might make students feel alienated or mean that there's something that they don't know that you assume they know that would stop them engaging with the assessment. Then accessibility. This is largely stuff that barriers to individuals, reasons a particular person can't access your e-assessment. And finally, integrity. These are the sort of things that you do to make your job easier, but which might make students' lives harder or make them perform worse than they should relative to their other students. Subjectivity. This is the term I first encountered in Sarah Hottinger's book, Inventing the Mathematician. And the idea is it's about, does the student believe that they are the subject of your assessment? Sarah Hottinger's book gives many examples of questions which either support stereotypes or have a very restrictive perspective. So questions where a female character is always a helper or a male character is allowed to make mistakes, and Eurocentrism in what kind of maths is covered. So things to consider. First of all, gender and ethnicity are really about who you portray in your question prompts. Try to avoid it always being men. Try to avoid it always being people from the same part of the world as you. Something that's not as obvious is the names of people. It's quite hard to think of names that aren't from the same sort of background as you. And even when you don't have named characters, make sure you use a sensible mix of pronouns. Just picking at random is a good way to do it. Culture can be a barrier. If you use references to TV shows or films that students haven't seen, then they might miss something. You might think it's fun to set a question about Game of Thrones, but if the students don't get the references, that might make it a bit harder for them. Or there might be a really good reason why that student doesn't watch Game of Thrones. Be aware of relying on common knowledge. For example, the fact that there are 11 players on a football team, don't assume that students know this. In the UK, we have a national speed limit sign which has no numbers on it and whose meaning depends on exactly where you are. So don't assume that students will know what that means. Now, these cultural aspects and these knowledge aspects quite often go along with class. So, for example, a question all about a skiing holiday that begins when Sarah spends X thousand pounds on her skiing holiday. I have no idea how much one would spend on a skiing holiday, and that can make students feel alienated, like they're not the same kind of people that you're expecting to be in this class. Geography, there's a couple of things here. Think about where things typically happen. Here in Newcastle, I've often caught lecturers setting big mistakes happening in Sunderland, which is nearby, which I have a big rivalry with. We have students from Sunderland, so I'm sure they don't feel great about reading questions about that. Make sure that there aren't certain countries that you only ever refer to as holiday destinations or places that people who need help come from. And finally, family. Not everybody comes from a classic atomic family of a mum and a dad and kids. And not everybody has exactly that setup. So try and vary the people that you portray in your questions. And where possible, use statistics to make representative choices of all of these aspects. Accessibility. Think about what you're assessing. Are you assessing whether the student knows how to plot a graph, or are you assessing if they can use your plotting tool? Often when accessibility comes up, it's to do with physical disabilities, to do with the way the student interacts with your assessment system. But you also need to consider non-physical disabilities that might affect how a student processes the information you're giving them, or their ability to engage with the content. So the first thing pretty much everybody thinks of for accessibility is, can you use a screen reader? So every system should be usable with a screen reader. And that also often means usable with just a keyboard, not a mouse or a touchscreen. So that's well covered. It's easy to forget about things like colors. Never just use color to convey information. This is something I'm always on top of because I'm very colorblind. And contrast is important for people with visual impairments where they need very strong contrast between colors. Firefox has a very good accessibility inspector you can use to check that you're coping with that. In the text of your questions, use as simple language as possible when you tell the student what to do or when you give them information. It makes it less likely that they'll misinterpret. In your instructions, be as clear as you possibly can about what you want the student to do without giving away a method that you might want them to recall on their own. Everybody's bad at reading instructions, and don't rely on conventions. For example, don't use the word simplify for an expression because that's very ambiguous. When you have images, make sure you give alt text for them so it's read out by screen readers or assistive technology. When you have videos, make sure that there are captions, and when you have audio, make sure it's transcribed as well. Think about what you're requiring in terms of motor skills from the student. For some people, just using a mouse is a massive effort, so just clicking on things repeatedly is going to take much longer than other students. And try to offer multiple input methods for any interaction. For example, for a drag and drop activity, allow a mouse, of course, but make sure a student can also use a keyboard to rearrange the items. In general, be very careful when you have a new interaction type. The built-in input methods for most systems can be relied upon because the developers have done work on accessibility, but things like interactive graphics, embedded tools from outside the system, you need to think about, can every student use this interaction? Finally, integrity. This is about the things that you do to protect the integrity of the assessment, make sure it's fair. My slogan here is, one cheater is less of a problem than 100 students giving up. Things that you do to make sure that an assessment is fair could affect some students more than others. Strict rules cause problems. For example, if you limit when an assessment is available, are all of your students sure to be free at that time? What if their internet breaks and it's a very restricted time period? If you give longer for students to access something, then it's more likely they'll be able to complete it. You might need to tell the student to enter their answer in a certain way because of a limitation of the system itself. For example, you might need them to use a particular letter for their constant of integration. That's your problem, not theirs. Certainly tell them what they need to do, but if the student enters an answer that would be reasonable, make every effort to accept it. Try to minimize the times that you have to give students this sort of instruction. And finally, limits add pressure. If a student only has a certain amount of time in which to complete an assessment, some people respond better to that than others. If there's a limit on how many times a student can submit an answer, that can cause problems. For example, if a student just submits an answer by mistake. Finally, if you want to limit how a student navigates through an exam, for example, they can't go back to a question they've already answered, that promotes bad exam technique, really. You should always allow a student to go back and change their answer. So that's just about it. Again, I'm not an expert on these sorts of things, and there are some references in the transcribed version of this talk. Thank you.
Thank you very much, Christian. So I think everyone agree that gives a lot to think about when we're creating questions. So again, please direct some questions into the Moodle site. Martin Greenhow comments there on randomizing gender and pronouns may still be problematic since not all students identify with either male or female. So he, she, his, her, etc. could be a problem. I have a randomized database of recognizably ethnic names that reflect the national balance. Why not allow students to choose their own colors and store them in a cookie? Do you want to talk a little bit, Christian, about how you approach this randomized names problem in numbers, perhaps?
Yeah, I think I did the same thing Martin did. I downloaded data about children that were born roughly 18 years before our cohorts came in, and counted up frequencies of names, basically. So we can pick a random name and it will be statistically representative. I don't think you can do much more than that. It doesn't transfer well to other countries. For example, when we gave a talk in Ireland, they noticed the lack of Irish names, so you sort of have to do this locally. But yeah, that's a fair way of doing it, and it makes it a lot easier to do, really, just having a function that gives you back a name. Martin's right about pronouns. I identified neutral names, or names that were commonly shared between male and female, and it will every so often pick up someone, it'll use they, them, their pronouns. Yeah.
Thank you, Christian. I think this the stuff in your talk goes actually beyond just the assessment of maths. It could be applied to many subject areas. From your perspective, how far behind do you think we're behind other disciplines on this, or behind the sort of, is the assessment of maths behind the teaching in terms of all these considerations, or do you think we're doing okay?
I don't know, really. I think because we do so much stuff that's to do with text, it's possibly easier, but also it's much harder to make mathematical notation accessible using the standard VLE things. So we have to go off and produce your own web pages that use MathJax, for example. So I don't know where we would be in relation to other subjects. I think the other half of the talk about inclusivity, I think we're way behind some other subjects in terms of thinking about the cultural place of maths in the world, and using that to inform our teaching.
Yeah, thank you, Christine. Question from the Zoom chat here. Can screen readers read handwriting? We need to give lectures as alternative lecture replacements. Typed material is the basis, but I usually write during lectures. How do I make this writing accessible?
So the way screen readers work, it's not that they do optical recognition on what's displayed. A screen reader on a web page will access the text that's in the source code of the web page. So if you're I think if this is referring to a recorded video lecture, you'll have to go through and type up your own subtitles or make your own transcription. The transcription for my talk, first of all, I did the subtitles over that video, and then I've placed the slides alongside the transcribed text, and then added extra. The images have separate descriptions, which are not just what I was saying. They describe what's shown.
Yeah, I'd recommend that everyone goes and has a look at the web version of this talk. It's a neat way to present things. Okay, I think that's all we have in terms of questions. So I propose that we wrap up the session there. Let me just pull up the program for this afternoon, if I can find it. There we go. So we have 2 longer talks this afternoon. So this is 4 o'clock British summertime this afternoon. So one on online STEM assessment from Jake Medina in the US, and one on innovations of eating of statistics for non-specialists. So we look forward to seeing some of you this afternoon, some of our American friends joining us. So I shall wish you a good day, and we'll see you later on. Thanks, everyone. And thank you to our 3 speakers this morning. Thanks.